Hi, my name is Karthik. Another short demo, I'll walk you through a real-time bus tracking system I built entirely using Palantir Foundry and AIP. I wanted to work on something that solves real-world problem in an operational setting, so I chose to track public buses in real time using live data from the UK Department for Transport, and I also referred one of Palantir's resources to help me through this project. Think of this as a lightweight transit monitoring tool, something a city could use to visualize traffic flows, trigger alerts when buses deviate from routes, or monitor coverage in under service neighborhoods. The core of the project is a custom compute module written in TypeScript. It fetches XML data every 10 seconds from DFT API. This is the part here, fetches the bus data from here. And using the XML to JS, we extract the fields into, it gives us a XML form data, we turn it into JSON data. And then we extract key fields like location, vehicle ID, trip details, and push the data into Foundry streaming dataset, right? So one of the key things I like about Foundry is the way ontology works here. Uh, Ontology, so to get the complete benefit of the ontology object type, we need to structure it in a certain way, right? And that's why this is the core of what I'm going to be structuring my ontology object type is the vehicle ref, latitude, and longitude. So it transforms ontology matters here because it transforms raw data into real world concepts like buses. It provides like a semantic layer that apps, APIs, and users can all interact with. And also one of the things it does is like push row to the Foundry, right? This just pushes the stream, whatever data we get, we can push it into the stream for Foundry stream, right? Piecing those two together, we have our main function that fetches data and pushes it into the Foundry stream every 10 seconds, right? Then this module is containerized using Docker and deployed in Foundry. If we can get there, so it runs continuously, right? So this is the container uh, versus container registry where I posted the bus container. Uh, API credentials are securely pulled from the Foundry credential store, and the target stream is dynamically resolved using the compute module environment. No hard coding required here. So once data is formatted, it is sent to raw streaming dataset using Foundry high-scale API. Foundry lets me auto-generate the schema from sample payload. I simply filter out extra regional fields to keep the stream lightweight and useful. So this is what I got. Like I just kept this recorded at time attribute. And this is the monitor vehicle journey struct is the main attribute that I'm interested in. So I then built a pipeline in Foundry to flatten the nested structure of the data using the flattened struct. This is what you can see here. Uh, Using flattened struct, I extracted like fields like latitude, longitude, vehicle ref, and time-based metadata. This gave me like a clean, normalized table of buses, refreshed in real time, ready for spatial analysis or historical archiving or whatever you want to do. So to make this dataset actually usable across applications, I modeled it using the Foundry ontology, which I discussed previously. Ontology is the semantic layer of the Foundry, again, where raw rows becomes real world concepts like buses, stops, whatever you want it to be. I created a buses objects, used a vehicle graph as a unique identifier, and constructed a geopoint using latitude and longitude of each vehicle. Uh, this allows like other tools in Foundry to reason about this data like objects, not just rows in table, right? So I can show you the live demo of what this is actually about. So here we are looking at Object Explorer in Foundry, powered by the ontology I defined earlier, right? So let me just, there you go. So I'm hoping it just, yeah. For example, right here, each circle represents a cluster of buses currently live in the system. The number inside the circle indicates how many buses are in the area at the moment, right? So, for example, right here there are 245 buses. If you were to go somewhere to the outskirts, you'll see only about 5 buses, 3 buses. You see the number slowly deteriorating as you go to the outskirts to the less dense areas, right? So that makes sense. So this clustering happens automatically based on the geopoint I defined in the ontology, which combines the latitude and longitude of each bus into mappable objects. What's powerful here is that this isn't just like a static map, right? It's like live streaming data. Each circle represents a real-time vehicle moving through the city, updated every few seconds by the compute module ingesting fresh data from the UK's department transport feed, right? So this project simulates how government or logistic firms could use Foundry to monitor fleets, detect anomalies, or analyze coverage gaps in real time at scale. And what's great is that I didn't have to build my own infra. I could focus on logic, modeling, workflow, design, because Foundry handles schema, evolution, streaming, versioning, and secure credentials out of the box, right? Wrapping up, in this demo, I built a live ingestion pipeline with compute module, a raw stream with schema validation, a transformation pipeline to clean and flatten data, and ontology model to visualize live bus feed, as you can see right here. I'm excited about this project not just because it works, but because it reflects how I love solving operational problems by building usable and scalable real-time systems. That's why I'm deeply interested in the forward deployment software engineer role. I thrive in fast-paced, ambiguous environments, and I'm passionate about working at the intersection of data, engineering, and user impact. Thanks so much for watching, and I would love to discuss this further or dive into the code if needed.